Hello everyone, I'm gonna make a short video today. So I reopened this project that was the project from the last time, and all I did recently is I updated all the dependencies and I updated my computer's BIOS. And for some reason now the FPS is struggling a lot, so I did some experiment, and what I think is happening, and it's maybe even happening to other viewers of the videos, is we're just drawing so many sprites at this point. I think we're just drawing too much, so we'll need to implement some sort of batching strategy, and I'm just gonna create like big textures that I'm gonna draw to for the floor. And I'm also gonna, so if I do it for the fog, a single texture, the problem is that it's gonna change the way that the fog kind of mixes with the environment. So I'm gonna have to do it in multiple steps, but the first step is gonna be, we're gonna create one big texture for the whole floor, essentially, which we'll have to update, but less often. So I already did some tests, in create systems here. I was testing out a little bit earlier, for example, if I disable the content rendering, and I really don't know why the frame rate dropped, it's very mysterious, but if I disable the fog, it's already a little bit higher, I believe, but it's very weird. I wonder really what happened, because I didn't touch the program. And then if I disable the floor, it's at 120. So it must be these systems are drawing too much, but it's very strange. I would think maybe there's been a change in the SDL API. They're still developing version 3, and I'm always updating from the main release, so I might have a bug there that I kind of inherited, but it doesn't matter because it kind of highlights that we're just stressing the system a bit too much, I think. So for that reason, we're going to look into that idea of how do we batch the different rendering. Alright, so we already have a script here called render target, which contains a few things. So I have a structure called a render target, which is just a texture and a size that can be pre-calculated. And then I have a dictionary of render targets, which is defined from the mlib. And then here I can add a new render target to the dictionary under a certain name for a certain size. I have a function to switch to a render target and a function to kind of clear out the render target before drawing to it. And I used this before, it's been a little bit though. But first of all, let's think about it. So we're gonna have like we're gonna create an object. I don't know if we can call it a prefab. So I'm gonna go in the init for now. Tile selector. This is the debug info for the tile selector. We can create the entity here, perhaps. So I'm thinking about we create. It doesn't really. Yeah, we're gonna have the entity. We're gonna have the entity, but it's the render target is gonna be apart from it for now, because I want to start simple, essentially. So we're going to create an entity. This is going to be called the tile floor. It doesn't have to inherit from any prefab or anything. And we're just going to add all the elements to be able to draw it in the same way that we're drawing the current viewport. The floor will be this kind of big texture, so we'll need all the elements to draw to it. So we need an origin, boundaries, a sprite. We can just add the origin. Oh, give me a second. Just gonna do a little thing. Otherwise the fan system is gonna kind of blow out. Oh, I think I just noticed why my graphic mode switched back to hybrid. It's supposed to be on discrete. That's probably why the frame rate dropped, but it still gives us the experience of a lower PC, so it's good that we fix this issue. So I did a BIOS update, so I think something got updated there. Okay, so we're gonna add to the ECS, we're gonna add an origin. We're gonna have some boundaries. Let's take the boundaries and let's set their size. For now, let's set it to some sort of size that we can wrap our eyes around. Let's just leave the color default and stuff. That's good. We're going to have a sprite. We need to use ensure. And for the sprite, we have the render type. What do we have? We have these kinds of all these types. But we're gonna render we're not gonna render anything from the atlas. So we need a new type, which is gonna be render target. And this, we can just give it a name right away. Let's name it RT floor, something like this. At the top, I'm going to define sprite render type. I could just say target. It's gonna be more like easy to read. Let's go back to our error and let's remove the render part. So let's go here and at the very top, let's include render target.h, and in the init, before we create this entity, actually not in the init, we're going to go in the singleton and we're going to use the dictionary of render target called RTS. We're going to create that, and then in the init, where we are here, we can just can just init that. Init the render targets, and then we can add a new render target using our renderer. We can add to the RTS. We can have a new render target. Now I don't know if I can do it like this, I don't remember. RT floor, and then the size will be the same thing. Something like this. So we're gonna have a new render target here. The thing is, like, I'm gonna have to kind of rework all of that stuff eventually, but I don't think it's gonna render right now. Let's just verify the system, because there's the grid element here. I don't think I can make that optional. This object that I'm making doesn't really need a grid element. It's kind of a bit superfluous right now. So we're just going to add the grid element. This object also needs to have some sort of a tag, so that it renders as part of one of these systems here. So it can either be board content. So I'm gonna go and add it to floor tag for now. And I want to just, my expectation is that it's gonna crash on a critical error if everything is at the stage where I think it is. So we're gonna have a, I don't even remember how these are called, draw batch. I'm coding too many projects these days, so I get mixed up between them. It's an init. I was lost for a second. Alright, so now it should crash on a critical error. Yeah, so critical error, unexpected sprite render type. So because the floor gets at this stage, so something else that's gonna happen is, so the floor is gonna get rendered pretty soon. I'm gonna write the switch case so that it gets rendered and doesn't crash the program. But then we need to render stuff into that render target. And so when we, I think Right now it's in set the cells validity. This is where we do this, but we just need to say like these sprites instead of rendering them to the main. So I think basically in the sprite draw we'll have a system where we can say, instead of rendering, like skip your render and just cache it to a texture instead. Maybe it could be a different system. I feel like it's starting to get a bit too big, but I don't have a lot of I didn't really pre-plan everything. I'm kind of exploring a little bit everything, so it seems like it might be a good idea for now. So in sprite we can have a boolean called render to target, or should render to target. Should render to target. And then we could have another. We could have a another string for the name of the render target, maybe something like that. So all the cells in the prefab that we create at the end here. Well, they don't have a sprite right now actually. It's in the function set cell validity. No, it's not there. It's here that we add the sprite. What we're gonna do, it's a bit messed up. I really need to do like a session where I clean things up. Maybe I won't record that since it's gonna be less interesting, but if you'd like to see this, just let me know. So we're gonna have a sprite, and then we're gonna say that it should render to a cache, and we're gonna say that all the cells will render to the cache called RT floor, like this. Alright, so I think we're starting to have the correct setup now. In the system sprite draw, when we come here and if we should skip render, that's something. But then if the sprite should render to a target, maybe we could do something. We could use our function. We have a function. I don't remember what it's called. It's here. It's called render target switch. So we're gonna switch, and then let's get the app renderer. Let's get the app render targets, and we can create a string, and then we can init the string to a. We can init the temporary string to the render target C string, so we can pass it. We need to disable the constant here, and ECS get mutable, and then use the ECS ID on the app singleton for now. Okay, so we switch render target like this if it should render to a target, and I think we should have another boolean to verify if is target cached, and if the target is cached, is not cached, sorry, it's cached, we could just continue and skip the whole loop. So after we switch here, and then we are going to render to that target, we can say it's cached now and don't re-render it the next time this system is called. There might be a better way to do this, honestly, but let's just approach it like that for now. So we're gonna switch target here, then we're gonna go into our default, but instead of rendering to the main renderer, we'll be rendering to that texture. And then after here, when we're done with the switch, we can do kind of the reverse and switch back. So we could say if we can check if the sprite is supposed to be rendered to a target, and then we can basically render target switch, use the app renderer, the app render targets, but then instead we just create an empty string. This is gonna reset in the way that I think I configured this. It should reset to the main render target. And after this, we're gonna say that the sprite is target cached equal true. So next time this specific entity is coming to this system, it will just exit here, and this is gonna be, I don't know how much the cost will be, but probably not that much. So now all the entities are getting rendered to the render target, and we can create a new case for our target. And now this case, for now, let's just break out of it. So what we should now see is nothing, no tiles, and no crash. Yeah, so there's not much there. Now if I go to the system, I'm just wondering why nothing else is rendering, but what I think is happening, we go to the sprite and we have to make sure that the sprite in the constructor, we have to make sure to have false there, because if the memory is uninitialized and it's not 0, that's true. So just make sure we have some false there. Maybe that's the reason why everything else disappeared. Yay! So that's good. Let's just disable, but through the system. So let's go to the system and let's disable the rendering of the board content. I want to see if we just, the performance and stuff. So it should be max now. It should be excellent. Ignore the text. We could disable them as well, but we'll keep them. So now nothing, the sprites are being rendered to the target, but the target isn't being rendered to the screen. That's what's happening. So in the sprite draw, I'm going to create a new case for rendering a render target. So it's gonna be pretty simple. So the idea is that the destination that we have here being created, which is the origin and the size, we're also going to use it, but instead of calling something from the sprite atlas, we're just going to use SDL render texture directly using the renderer. In terms of the texture, all we have to do is we can essentially recover the render target that we're interested in. Render target, and then to recover it, we can just use the getter here on the render target dictionary that we have, and the name that we're looking for, we can just create it from a temporary, so string, then we init set it to, you know, the RT name like this. Then we pass the string, and here we can use RT texture to get a texture. We render the whole atlas, and we can use the destination there. And then after, we can clear the temporary string like this. This is this will have to be another temporary, maybe. Yeah, it's gonna be like that for now. Oh, actually, wait a second. Let's go back to the init. So I create the sprite, I gave it name. Yeah. So it's the, we don't need this. We don't need this. We already have a name, right? Which is the temp. That's a, this is the one that we need to be different, temp to, like this. All right. So now you can see that we're rendering essentially all the tiles to one big texture, and then we're rendering part of that texture. And as you can see, the texture is too small right now. It's smaller than the resolution of the game. But if I go in the creation here of the texture, I can change the size. This is the size that I want the final resolution to be. So I'm going to put the texture to that size. I don't think it's going to pose too much issue. Alright, so that's good. And then now that all these sprites are being rendered as one, I'm wondering if we can try to reactivate the other system and just see if the cost is still going to be fairly high. I imagine yes. Yes, there hasn't been a lot of changes. The reason for this is I imagine it's the transparency of the fog that's costing the most, because it's a lot of small objects that have a lot of different like a lot of transparency. So what I'm gonna do is I'm going to do the same thing for the fog right now, but what's gonna happen is it's gonna break the effect of the fog. But I just want to test my theory essentially, and it shouldn't be too long. So I'm gonna go here. I'm gonna have another layer called fog, and I'm going to create another entity that I'm going to call tile fug is going to be RT fug, and we're going to add it to the draw batch board content. Is that it? Is that the name? Board content. We're going to have it like this. So then the fug itself, which is a prefab. So each fug, which is here, this the sprite, I'm going to say that they should render to a target, and then the target name is going to be RT fug. Oh, we ran into some issue where maybe I did something wrong. So let's just go look at everything. Yeah, because I reinitialized it. That was my error. Right, neat. So as you can see, the performance is back to 120, which shows you that you can, if you were to batch everything, you would get an increase in performance. Now, the downside from this is that basically, like, it's gonna be very flat now because each tile isn't gonna mix with the other objects. But I wonder if there's a solution around this. So that's what I'm gonna think about. I think we could consider rendering strips of fugs. So instead of rendering like a single render target, we would have a set number of strips, as many as there are rows, which is quite significant, but it would still reduce the amount of calls by a lot. So that's what I'm probably going to try out, is creating individual strips of fug so I can sort them and still have a sort of a batching feature to increase performance. But overall, I'm pretty happy with my test. Now, I also know that it's probably due to me resetting my BIOS that I lost this performance, because as I was just explaining, the graphics configuration of my laptop suddenly reset to what's called an hybrid mode, which is not what I would like. So thanks for catching up. This is going to be a pretty short video, but hopefully I demonstrate the idea, and I'm going to think about and maybe do some tests so that I can render different rows of fug, and then once that's sorted out, we can proceed with our ideas. So thank you for watching, and have a good one.